This is Intro to Section 3.5. This is Part 2, as we're going to continue to talk about triangles and specific things about triangles. We're going to start with discussing inside-outside angles and how they're kind of related to each other here. It says an exterior angle of a polygon is an angle formed by a side and an extension of an adjacent side. Remember, exterior means outside. So as you're looking at these pictures here, the outside angle or the exterior angle in all of these pictures is going to be angle 1. It's on the outside of the triangle. Okay, that's exterior. It's on the outside of the triangle. And if you were to continue, again, what they're saying is if you were to continue this side and you would create this angle right here, angle 1, that's an exterior angle. Okay, this is for each exterior angle of a triangle. The two non-adjacent interior angles are its remote interior angles. So, in other words, the two angles that are furthest away from the exterior angle. Now, as you look here, these 2 and 3 are the remote interior. And remote means furthest away, essentially. Okay, those are the remote interior angles. So, as you're looking here, you see these two angles. These are the two remote interiors. These are the non-adjacent angles. Remember, the adjacent angle would be that angle right there. These are the remote interiors. They're on the inside of the triangle, and they're furthest away from the angle. So it says here, in each triangle below, angle 1 is an exterior angle. Angles 2 and 3 are its remote interior angles. Okay. Now, there's going to be a relationship that we're going to talk about with these. That's why we identified what these were first. Okay, now before I go through these two examples, let's take a look down here at the triangle exterior angle theorem. Okay, because we're going to use that on those two examples and be able to talk about that. The triangle exterior angle theorem says the measure of each exterior angle of a triangle equals the sum of the measures of its two remote interior angles. So in other words, angle 1, which is right here, the exterior angle, is equal to the two inside angles added together. Okay, so angle 1 is equal to 2 plus 3. Alright, the triangle exterior angle theorem. It's an important one that you're going to look at and use, especially on these examples that we're going to look at. Okay, alright, now let's go up here and let's take a look at the examples. Now, knowing what you know from the triangle exterior angle theorem, what I want you to do is hit pause and see if you can figure out the three questions, these two up top, and then this one down here on the bottom. See if you can answer the three questions that we have, okay? And then go ahead and play it and check to see your answer. All right, now that you have went through, completed these problems, we can take a look at a couple of different ways to find the answer. Okay, we'll start with this first one here. What's the measure of angle 1? Well, you'll notice on this, angle 1 is an exterior angle, and these two angles right here are the remote interiors. So essentially, angle 1 is going to equal those two added together, is going to equal 80 plus 18, which angle 1 should be 98 degrees. Now, there's another way that you can complete this as well. Okay, another way you can complete this. You'll notice that you have two of the three angles in the triangle. So you could say that this angle right there is x. Another way to do this, you could say x plus 80 plus 18 equals 180, or x plus 98 equals 180, and figure out what the third angle is. And you figure out that the third angle is 82 degrees. Okay, so now instead of that x, we're going to put an 82 in here. And you'll notice these two form a linear pair, so they should add up to 180 degrees. So if I take 180 minus the 82, it should give me 98. That's another way you could find it as well. Okay, now, letter B. Okay, letter B again, this is the exterior angle. These two are the remote interiors, so those two should add up to equal 124. So 124 equals 59 plus the measure of angle 2. And if I want to solve for angle 2, since that's what I'm trying to find here, I would subtract 59 degrees, and this would be 65 is angle 2. So I would subtract 59 from each side to solve it. In other words, I would subtract 59 from 124 to get that other remote interior angle. Okay, now let's take a look at this last one now. The last one, it says here, as we're looking at it, it says when radar tracks an object, the reflection of a signal the reflection of signals off the ground can result in clutter. Clutter causes the receiver to confuse the real object with its reflection, called a ghost. At the right, there is a radar receiver at A, an airplane at B, and the airplane's ghost at D. What is the value of X? So let's take a look over here at the picture. We're trying to figure out what is the value of X. What's the degree measure there? So a couple ways again that you can look at this. A couple ways to do this. You can notice again that you have an exterior angle and its two remote interiors. Those are the furthest away. So if I add those two, it would equal 80. So X plus 30 equals 80. And if you solve that, X would be 50. That's the easiest way to see that. Now, if you happen to not see it that way, another way to see this would be this way, is that okay, I'm just giving you another option. You know that these two are a linear pair. So if that's 80, this guy right here is 100. And then you can add the three angles of the triangle to add up to equal 180. So X plus 100 plus 30 equals 180, or X plus 108, or X plus 130 equals 180. And if you solve that, X is going to equal 50. That's another way to solve that as well. So that's a 50-degree angle. Okay. All right. So we went through the examples here talking about the triangle exterior angle theorem. All right. Don't forget to complete your WSQ with this. And this concludes sections 3-5, part 2.